So we had success with getting our task worker started and having it print to the console, to the output anyway. And implied in that is it being able to connect to Redis, so that's good. What is next? Well, we need to probably go back over to the docs, which I handily have open here. So it mentions using the RPOP LPUSH command. Let's see, let me think about this. So, like I said, I think one of the things we'll need to do is every worker, when it starts up, needs to have a temporary queue of its own, and use that to do this thing, right, where we pop from the main queue and put on our temporary queue. So how does that work? I'm not really convinced about the idea of doing this like this. So this works if, like, what does this actually accomplish? Thinking about this a little bit more, right? So we put it on a temporary queue, then we have to, okay, we process the task, we remove it from the temp. So what does LREM do? So many interesting Pokemon appearing in chat. LREM, what does LREM do? List remove, perhaps? Probably not left to remove. Removes the first count occurrences of elements equal to element from the list stored at key. Okay, and you can control the direction that it removes things from by using negative or positive numbers. Okay. So it says to remove one item. Remove elements equal to element moving from, okay. So we remove one thing that matches this thing from our temporary queue. So what happens if the worker crashes? There will still be an item in the temporary queue, right? If we did this literally, if we did this literally, where we say, okay, the worker runs, we run RPOP LPUSH to remove the task from the main queue and put it on the temporary queue, and then we process the task, and then we crash rather than completing the processing of the task. Now we have an item on the temp queue. So the next time the worker runs, like, all this is going to do, like, let's say there was a bug that meant we never successfully processed tasks. Then all that would do is just move everything that's in my queue into temp queue. That would be the effect. So what do we do about that? I guess I could keep reading. So they have some other things here. Blocking queues. It's no response. Means you pull the queue repeatedly. You can implement a blocking queue. If the consumer tries to dequeue a task when the queue is empty, it's put to sleep until a task is available. Okay. We might want to do this, actually, since we're going to have multiple task workers, potentially. Although the current setup with Docker Compose is just the single worker. But we could have multiple. And then we could have them block, waiting for new tasks. Using BRPOP. Delayed tasks. Sure. Priority queues. Pub subpatterns. Publish a message to a channel and consumers subscribe to channels. Yeah. So in this case, the message did not need to be sent to multiple consumers. Yeah. That's interesting. Okay, so let's go back up here. So is there if nothing else with this approach with having a temporary queue, if nothing else, it means we have essentially a place where things will accumulate should processes fail. So essentially like a dead letter queue, although things appear in there before they are dead. Before they're dead letters, they are in there, but effectively things that hang around in that temporary queue are things that we would need some other mechanism to retry by pushing them back onto the main queue. So I think this approach is good. Is there a RPOP LPUSH for like a blocking version? There is. As of Redis version 6.2.0, this command is regarded as deprecated. It can be replaced by move with the right or left arguments when migrating or writing new code. move. Source dest left right timeout. move is the blocking variant of move. When source contains elements, this command behaves exactly like lmove. Okay. Doing move right left is equivalent to RPOP LPUSH. Reliable queue. Please see the pattern description and the lmove documentation. Reliable queue. lmove or move for the blocking variant offers a way to avoid this problem. Consumer fetches the message at the same time pushes it into the processing list. It'll use the lrem command in order to remove the message from the processing list. This is the same thing we saw in the other documentation, but good to have another thing in the docs and probably kept more current. The actual documentation for individual commands, maybe. So let's try to do this. So we have our connection. In fact, I'm going to, instead of using print, oh right, we don't have any of the tracing stuff set up in this context, right? Because we had all the tracing set up in the common API lib. Okay, so maybe for now, I'll just print. But not hello world. There we go. Starting task worker. All right, and then we do want to loop forever, actually. But inside of our looping forever, we want to something like that. Actually, what other suggestions do you have, Copilot? Okay, different ways of using BLPOP. It's just changing the wording. Okay, we'll accept that. But we don't want to use BLPOP. We want to use BLMove. M-O-P-E. Right? And we don't want to use some hard-coded name. We're going to use an environment variable. So we're going to shift, there we go. get. No, I don't need a comment for this. So let's see. Let's see. We're gonna call this QUEU. Q. Where is underscore again? I think it's. Is it this key? No, that's plus. Oh no. Oh no. This key. There we go. Name. All right, cool. And then what did we actually call it though? In Docker Compose, we called it QName. Great. We could have called it task QName, but oh well, it's fine. There we go. Must be set. But probably. Interesting. So expect here. Panics. Yeah. Wait. I mean, honestly, on a worker like this, it might be acceptable to just panic and have the process die. Think about that for a second. There's something to be said for that. Yeah, I think I see, right? So this is why... Okay, so we should be able to do this, I think. So we don't need the question mark here. Because expect should guarantee that we get this type T, which will be our client. What if we did this? How do I... so hard getting used to this keyboard. All the layers and all the things. So let's see. Nav. So I want control right arrow. That's just what I did to myself, right? I was like, I can do this. And I can. It's just gonna take some time. It's gonna take some time to learn where all the keys actually are. So Control S. Wait. Okay. There we go. What am I missing here? Open, .get connection, expect. Oh yeah, we don't need that match there anymore. I was gonna get rid of that. Right, so no named, no method name get connection found for result. Right. Returns the contained OK value, consuming the self. Foxy Blue is lurking. Thank you for lurking. Enum result and the current scope. So I would have expected. Wait. Oh, I see. So we're missing a layer of expect, right? So this expect is about getting the environment variable, but we also need an expect here. So basically what I'm thinking is that instead of trying to use match and trying to like unpack the result to get the okay or the error branches, we're just going to panic the process if something fails. And that would be more awkward in the context of our web services where we are returning like HTTP responses. We don't want the process to panic. It's not going to crash the server inside of Axum, but it is going to mean we don't get a meaningful HTTP status code in the response. But this is not an HTTP, API endpoint thing. Okay. So that works. We have a connection. Now this is complaining. No method name BLMove found for struct Redis connection. Okay. Right, we're probably just need to import Redis commands, maybe. And then get some complaints about things. A cutie fly appears. Okay, I don't know why VS Code is complaining. It's something probably to do with Rust Analyzer. Expected unit type, found enum, right? So now here, okay, we're gonna run a quick ad break while I think about this so that we can eventually get rid of pre-roll ads. So you may get an ad if you're watching this live. But I guess you could always subscribe. You don't need to, but that is always an option. All right, so anyway. Yeah, so what I'm going to do is I'm just going to panic. That is to say, I'm gonna expect, right? Instead of, oh, Copilot had the, there we go. Accept that. Kitty fly escaped. Oh no. All right, so that should make the warning go away. All right, so 3 arguments to type direction. Direction and F64 are missing. Okay, so BLMove is supposed to take a bunch of things, right? I changed this to be BLMove from whatever it was before, and so now we're not passing the right args. Go figure. All right, so cool. I'm gonna take BL name. There we go, BL name. Or Q name rather. Okay, I'm gonna. Can we do something to stop this from popping up? What if I just ignore it? Okay, what are the args for BLMove? Can we see that? There we go. Source key, desk key, source direction, desk direction, and timeout. So the source key is where we're reading the message, the item key from. So it's a list in Redis. And then we need our temporary queue that we're going to be putting our item that we're working on into. probably I want to also have like a temp queue name here. So we'll do like let temp. Where is underscore again? It's right there. We could do that. We could just like format, like add :temp on the end. All right. So then we will do. I don't know why we would need to clone that, but we'll do temp. Someday I will actually. There we go. QUEUE underscore NAME comma and then a direction. So according to the docs, we're doing so if we go back here, there was this explicitly said, it said doing BL move right left is equivalent to the thing we were going to do. So I don't know where we're getting direction from, but we'll try DI. Yeah, there we go. So Redis direction right, comma, and then DI, yeah, direction left, perfect, and 0 timeout. So we're just gonna block forever. Maybe you wouldn't actually want to do that in practice. Let's think about that for just a second. So you could potentially have something where you wait a minute for a message, and then you could, like, I don't know, send a trace, right? Saying, hey, we're polling. And so you'd have a loop for that where you would just be, you would be polling, you would block for a while, and then you would trace so that you could have monitoring to check to make sure your worker was actually looking at the queue. Maybe there's actually a way, I don't know about instrumentation on the Redis side, you know, thinking from like the operation side of things for like in real life, doing something like this, where you actually, where it matters, you might want to maybe have some kind of, you might be able to, I don't know, because I've not really, it's been a while since I've used Redis in production, read many years. You might have some ability to like monitor for, is stuff checking the queue? Is it like polling? Is it looking at it? I don't know. That's a possibility. Or you could, you know, have instrumentation on the consumer side. So let's try to save this, and maybe eventually this thing will stop popping up. Okay, so this has to be a floating point value, so we have to put 0.0 here, apparently. It can't just like take a 0. All right, and it doesn't like this because we have this value. Nope, that didn't fix it. Use of moved value queue name. Value moved here in previous iteration of loop. Move occurs because queue name has type string, which does not implement the copy trait. Consider cloning the value if performance cost is acceptable. What else could we do? So, is there a way? As str. So there's a string and there's an str. So now we have a string reference. Does that improve the situation? Temporary value dropped. Oh, hey! Thank you for the follow, RayG1660. We are currently have a follower goal of 90, so one more to that goal. And now, because I got affiliate here on Twitch, we have a sub goal as well. Hey, what am I making? That's a good question. I should probably talk about that briefly. So this is a project that I started a few weeks ago, and let me step back here. So we have a top level README, and there's actually a repository on GitHub. Let me grab this, and we'll put that in chat for reference. There we go. Glowing Telegram doesn't mean anything. It's just the name, but it's a little meta. But this is a project for managing like all the recordings from these streams. Because what I do after the stream is I have a local recording and I do some very light editing, and I put them on YouTube. I put in like description and stuff. And what I'd like to do is I'd like to do that better. And this is a tool that's the idea is to help me do that by having a web UI using React Admin, so that I can get all the metadata about all the videos, video clips from the stream, and then be able to do speech to text to like transcribe all the text of that, and then take all of that text and send it to GPT-4 through OpenAI's API to do like a summarization. Also do some like audio analysis. A previous stream we were working on identifying silences within the audio of the stream, and then basically bring all that metadata and all that analysis together to like identify interesting parts of the video, to like do automatic clips and highlights, and eventually to be able to provide like a file that I can export from this tool into my video editor, and then like auto generate videos from that. I don't know if that will actually in practice ever be like, it's not going to be 100%, but I'm hoping it will at least make it easier for me to do more interesting videos on YouTube from this. Yeah, I thought it was an interesting project. There's kind of like, so all of that is kind of like the why of the tool. There's a couple other things too. One is I wanted a project I could work on stream for these coding streams that I'm doing. Rust is mainly because I haven't used Rust, and it's a cool language, and not it's a okay fit for like doing these little microservice API things. So we're also using Docker and Docker Compose, and we have a bunch of little Rust-based microservices that are implementing all the backend pieces for the overall application. And then the front end is TypeScript and React, using Vite and React Admin, which is a library that I've used before that provides all the CRUD UI stuff, and then Nginx to like serve as a reverse proxy for everything. So that's the project in a nutshell. In a nutshell. All right. So it's not happy with what I'm doing here. It says temporary value dropped while borrowed creates a temporary value which is freed while still in use. Consider using a let binding to create a longer lived value. Okay, right. So we have this string that we get from .env.var, and then we're trying to convert it into this str reference. I thought that would be a good idea because that at least makes BLMove happy. What is the right thing to do here, right? So if we didn't have this as str, right? So then this would be a string. And then this complains, right? Because what we essentially are doing here is we have this value Q name, and then we're looping, like we're repetitively trying to run this BLMove command in Redis, and so we are essentially borrowing this value Q name over and over again, and it says value moved here in previous iteration of the loop. So like the first iteration of the loop, we borrowed the value queue name, and then the next iteration of the loop, it was already borrowed by the previous iteration, which is an interesting thing. How do you... Huh. What? Why did we not have the same error about connection? Right? Because we're also using con. The difference is this is immutable. A mutable, not immutable. What if this was mutable? Does that change anything? Nope. A variable does not need to be mutable. Yeah. So this is my lack of Rust knowledge at work. But why? Let me oh, right. Because string doesn't implement the copy trait, but I guess connection does have a copy trait. So if I control click and we look at, there must be an implementation of connection or copy, the copy trait for connection. And that's why things do what they do. Somewhere in here. Somewhere. I'm going to assume it exists, I think. SOC key. Oh, just pass a reference. Yes. Ooh, of Vulpix. Hey, Future Highway. Welcome to the chat. And thank you for the suggestion. It's really appreciated. Yeah, I think that makes sense, right? So, because I guess what we're doing now is we're passing queue name, like the whole thing. Or trying to. Okay, so now I just need to figure out where on my keyboard the ampersand key is. I think that's in a layer. Yeah, so that's like L. Aha. All right, probably the same thing for temp queue name too. So, okay. It was a good suggestion, it seems. All right, so what are we doing? We got a connection to Redis. We are trying to do a blocking move from the head of the list at queue name. Although SOC direction right, that's direct. What does this actually mean? Well, let's go back to the docs here for one of these. BL move. So BL move source destination contains elements. This moves. Well, let's look at L move then. Oh, Vulpix escaped. Returns and removes. Oh, it returns the value too. Okay, that makes sense because we are getting a string here as task. All right, and it pushes the element at the okay. Removes the first last element, head tail depending on the where from. What do you mean the where from argument? Which one is the where from argument? That's cute, right? It refers to this name of an argument, but it's not in here. And where to. So I'm guessing it's referring to this is where from and where to. So we're reading from the right. Wait. First, last element, head, tail, depending on the where from argument. So is the head the left? I mean, I guess that's arbitrary, but we'll say that the head is the left, right? So but So the reason I had right left here is because Oh, here we go. Here's an example. So source, which is our queue name, holding list ABC, and destination holding list XYZ, executing lmove, source destination right left, which is what we have here, results in source holding AB. This seems backwards from what I thought we wanted. So in the example that we were looking at, we're looking at RPOP LPUSH. No, I guess that's consistent. Okay. Okay, so we're gonna do that. So we're gonna get the task. We can, of course, when we get to the part where the task API is adding things to the queue, we can ensure that it's adding it in the right direction. So we're gonna get a task from the queue. So this task is actually, it's just like a key where the record lives in Redis, which is why it can just be a string, and that'll be fine. And then what? Well, we're going to do some work, which is the to-do here. That'll be interesting to figure out. I think we're gonna have to, there'll be some code there. We'll make some HTTP requests to one of the other microservices to actually do the work. Rather than doing the work ourselves, the work of the task worker will be to call other things. And then we'll finish the task, right? And when the task is finished, then we need to remove the item from the temporary queue. Okay. I don't think we need to actually get the result here, so we'll get rid of that. And then we want to take just one item with the value of task from temp queue. And again, if anything fails, we're just going to panic. And we're going to exit. Let's see. All right. Key count value V. From Redis value, bool I size, use size, and 44 others. What about this? Which ones? Does that make you happy? Nope. Okay. I might take it up on its suggestion of specifying specifying the arguments. Actually, let me undo the this part here. There we go, and I'll put count of 1 and save. Does that make it happy? All right. So it was confused about what the return value was, but this gives it the type hint that, yeah, we just want the unit result. So that is at least fewer characters than having to spell out the the generic arguments for generic type arguments. Okay, so this is looking good-ish, except for the part where we actually do something. But this should at least, this might work. So, yeah, let's build this and run this and see what happens. I just gotta figure out where, let's see, it's this layer and up arrow and enter. Okay, cool. Hello to everyone hanging out and watching. We have a little bit of time. Oh, Never mind. I was gonna say we have a little bit of time for it to compile, but I guess it's still going, but should be done soon. How are we all doing? Oh, there we go. Twitch briefly told me I had 12 viewers, but I think I scared some off. All right. Thanks all for hanging out. I hope this is interesting, maybe useful to some. Let's see. All right, so we have things compiled. I'm just looking for the Docker desktop. There we go. So here's our task worker. So we get a message starting task worker. And figure out how to make this all work together. So let's see. In Docker Compose, I said that the queue, where is it? Queue name is task queue. Let me copy that really quick. We'll go over here to Redis Insight or whatever it's called, and we'll keep this up too so we can see the console. There we go. And let's make. We're gonna make a new thing. It is going to be a list, and it's going to be called task queue, and it's not going to have any elements. I know, key with this name does not exist. I know, because we just added it. Congrats. There we go, task queue. Key with this name does not exist. Interesting. Kind of weird. Can we refresh? Okay, so that failed. Got it. Let's try that again. Queue, task queue. Element will be, I don't know, 1. Key has been added. Key with this name does not exist. What's going on here? Huh, what am I doing wrong? Let's see, browser, workbench. What is workbench? Oh, this lets us like run commands, right? All key types. Why can't I add a key? Like this should work, but it doesn't seem to want to. Huh. All right. Wait, we have Redis running, right? I mean, we presumably would be getting errors over here if Redis was not running. Let's look at the console here. Yeah, it's doing its thing. Task worker still going since we started it. How do we make a list in Redis? I'll do it by commands here. Right, so we can LPUSH. Maybe LPU. It even gives us handy dandy. Okay, so task queue, and we'll put in maybe when I put the element, I need to put quotes around it. I don't know. TEST. There we go. So if I run that. Okay. So if I go back to this and I refresh, why don't I see it? Integer 1. What does that mean? Man, I used to know how to use Redis. Like, I shouldn't have to do anything else, right? To create a queue in Redis, you can use the LPUSH command to add an element to the head of the list. Commands creates a new list called myQueue and adds the string task1 to it, right? So that's what we did. So where is it? So I realized something just now. So I did say I wasn't going to worry about setting up tracing for the worker, because all the tracing setup stuff was in the common API lib and whatever. But we are using tracing info to like log stuff, but that's not going to, I don't think that's going to do anything by default since we've not configured it. So instead, I'm going to just swap these out. What I'm hoping is that somehow, let's think about this. I mean, if this was actually working, yeah, we would immediately see our messages disappear from our queue, but we'd also expect to see our temp queue also exist. Now, granted, when we do quote-unquote finish working, so they're not doing anything, we do remove it from the temp queue. Maybe everything is actually working right now, and what we're observing is the result of that. I can hope, right? Let's see, what is... There we go. Try it again. Try to build again. All right. Let's revisit the kind of the outline of the stuff we're working on right now. I think it's going to make most sense to like continue working on this task worker and trying to get this working, because this is going to then dictate. This is going to define the shape of what we're going to be doing in the task API. It's going to also like lock down what the shape of the data is that needs to be in Redis for us to then call our other microservices. This is like the what's funny because it's like, so high level, well, medium level. The idea is that, you know, in the front end we're going to initiate something, and so in the React admin UI we're going to be like, take this episode or the stream and transcribe it, do speech to text, and that is going to then result in an API call to like a transcription API. The transcription API is going to then call the task API to say, here's a task to go and process this thing, call me back. And so all of these, like all of the microservices that have these complicated, like long-running processes, need to break down that work into like little segments of work, and then have APIs rather that do that. Like have a process this segment of this thing API, and then the microservice can call the task API and say, hey, call me back, do, you know, all the segments of this work and coordinate that and keep track of that. And it's kind of a, this is as far as I want to go in terms of microservices calling other microservices. I don't want to have, you know, a big tangled knot of different services calling each other. That's what I was trying to avoid by having this one thing. So hopefully that will work. Okay, I need to see, how long has it been since we've taken a break? I need to have like a counter. What time is it now? So it's been about an hour roughly. So I'm gonna take another break here, and that means I'm gonna run some ads so that we can stop pre-rolls. And I'll be back in just a couple minutes, and we're going to continue working on the task worker. Let's see, did we have... Okay, it is running. Let me... One last thing before we go. Let's try running that command again and see if we get any results. Right, so if we run this... Aha! I was right. It is actually doing the work. It's working so fast that from like the perspective of in here, the data is just gone. What's interesting is that means that like we're putting a thing onto a temp queue and then we're removing it from the temp queue, and I guess once the list of things is empty, the key goes away. So that is interesting. I don't think that is a problem, but it's interesting in terms of like that behavior. All right, I'm gonna take a little break for a couple minutes. I'll be back to work on this worker some more. BRB.